I analyzed disclosed GraphQL reports to see what works in real life, and it's incredible what a variety of bugs I've seen. Because I have to admit, before I mostly just tested authorization, so this was very valuable for me, and hopefully for you as well. Enjoy! In this video, we'll go through the types of bugs to which GraphQL led, and the most common one, of course, it was authorization. And I also have it split into 3 different groups: read, create, update, and delete. And we'll start with the read bugs. And this was by far the biggest group of them all, with as much as 59 reports. Some of them were pretty simple, like this one, where you have the query that fetches some objects in this type. It's some media from Instagram, and you don't even change the parameter to another user. It's not like the typical IDOR where you change the ID and you get the data of another user. Here, you just added the email attribute to the request. So along these medias, whatever it was, you would also get emails of users. And this is definitely valuable information, impactful information that Instagram does not want to have leaked. But the majority of reports were pretty simple IDORs like this one. And I feel like I've seen the same report like 5 or 6 times, copy-pasted report on HackerOne, because they had very, very similar issues, just in different queries. You just have some query, you change the ID, or in this case, the handle, and you just get the data of something you shouldn't be able to access. And here, this was $2,500 bounty. There were a lot of reports that were exactly like this one, with exactly the same bounty. Then there were some that were a little bit less impactful, so the bounty was a bit less, but the reports were very, very similar. So this is sort of the most typical GraphQL bug you will ever see. With this, we'll jump to the second biggest group, the create or update mutations. And we had very, very interesting bugs here. The most impactful one, I would say, was this one from Watson Group by Jfran Sibit, whatever, you should read this. And I understand from the summary, because the report itself is not visible, I understand from the summary the GraphQL was not supposed to be public. So the first step, which is sort of not visible from this part, is the discovery of the endpoint. Maybe it was under the different path, maybe on some hidden subdomain. But then the user could register on some website, and then as a registered user, they could also have the create admin user mutation. So they will go from being unauthenticated to being authenticated, but for low privileges, to being authenticated as the admin. So it was reported, it was rewarded as a critical. And I would say it was probably one of the most impactful bugs of the case study. Then, to complete the 4 operations you can do with the data, because you can read, create, or update, but you can also delete, which is always, I'm saying, you should also test for this, because it's less natural to test for deletion. It's a little bit harder to test for deletion. So bugs here will definitely happen. And the one I have here from GitLab, it is very, very interesting what happened here. So it's not your typical IDO where you just change the ID and turns out you can't delete the object you shouldn't be able to delete. It's the case where you have the mutation that's called destroy snippet. I don't know what snippet is exactly in GitLab, but we all understand what it is. And the title of report is, you can delete the repository. So how come you can delete the repository using the delete snippet mutation? And the answer is, the hunter used the identifier like this. So they used the destroy snippet mutation, but then they used this identifier, which, and we have the sort of source code analysis here, which caused this argument to not be a snippet but a div node object. And apparently the code that was there happens to just delete the repository when this happened, which does not make sense at all to me. Even by looking at these snippets, which seem understandable, it's hard to sort of accept how this could happen, but it's very, very interesting. And the good information is this type of identifier, this is not something GitLab specific. I've seen the same form of Git in HackerOne. I've seen the same in Meta. So this is not something created by GitLab. It is sort of more widely used. So if you're testing something that uses GraphQL, you can try to do this to sort of confuse what object are you trying to modify or delete. This video is based on the free part of the case study. If you're enjoying it, you will surely also like the full article, where there are crazy bugs like the idle that's only exploitable for 3 seconds, secondary path traversals, race conditions, cache-related issues, crazy things, and also you will get access to the whole database with all the reports, as well as the other 12 case studies. If you want to access them, go to study@bugbountyexplained.com. Next, we'll go to denial of service bugs, and we had a few reports here, but only one of them is from Bug Bounty that was actually rewarded. The other are 0 days. And if you've watched this presentation by Ronnie about practical exploitation of denial of service in Bug Bounty, you know that GraphQL has big potential to be vulnerable to denial of service bugs, and I can also confirm this from my experience that it is quite easy to find. The bigger problem is if you can get rewarded for it, because as those bugs go, they are a bit random whether the program will reward them or not. So it's always a bit of a mystery when you're reporting the bug. Here they got the bounty of, well, actually the base bounty was just $1,000, but then they got the bonus for the coolest bug of the whole event, because this was the Google event. So they got another $5,000 on top of this. So it was a really nice bug. They batched the directives, which were used in a little bit of an unnatural way for them. So it was very creative and very nice, and nice for Google to reward it as well. Then as the next group, we have SQL injection, and this one you can of course expect to some extent the SQL injection in the parameter, because GraphQL itself, it is not a database. It is not actually something that stores your data. What it does is it takes your HTTP request with the GraphQL query in it, and it translates to something that the developers implement on the backend. So it might be the HTTP request to some backend service. It can just be something that from you to the server, you send the GraphQL query, and the server makes different REST API requests on the backend, because it's much quicker for the server than it would be for you to send, let's say, 10 REST API requests. Another case may be SQL query, where the GraphQL query is transformed to SQL query, and the data is then returned. So normal SQL injection is somewhat expected, but the one that was here in HackerOne was really interesting, because it actually did not happen inside of the query. It's something that before the query is executed sets some session keys and values, and apparently it was used sort of internally without user input ever getting to here, so there was no problem with this. But then there was some other code, which I don't think is mentioned here, that caused the URL parameter to land in this session. So here you can see the request, and you can see there's not even a GraphQL query in this request. There is just the request to the GraphQL endpoint, and you have the query parameter with the fairly typical Postgres SQL injection payload with the sleep comment, and you can see the times here to confirm it. So a very interesting bug. I don't know if without access to the source code, someone would think that you should also test for SQL injection in the parameters of the request itself, not the GraphQL parameters. So it's very interesting and very cool bug with big impact. Of course, this was not rewarded because it was found internally by the HackerOne team, but they still submitted as HackerOne reports, and they sort of give reports the real severity, and this was a 10 out of 10, critical, understandably. Then we'll go to the next group, which is not something that I like, and if you're a long time viewer of the channel, you probably know this, because there were 3 reports that I found that were nothing more but reporting just the fact that the GraphQL schema was disclosed, which by itself is not a vulnerability. It can allow vulnerabilities to happen, and it can make the exploitation easier, but by itself, I don't think there's any security impact. But some people did report it, and this report that I have here, it even got the bounty of, I think he said between $600 and $800. So you can probably try to do it, but I would not advise it. If you have so much data, try to find what queries and mutations you can use, or do what we did, or the hunter did in the beginning of the video, where you have the usual query, which is something you have access to. It's not a violation of any access control, but you just add some attribute to it that all of a sudden leaks the sensitive data back to you. This is what I think you should try if you have the introspection. And finally, we have one last group, the CSRF, and I very much liked the finding that was here. It is actually not the bug bounty, it is the security auditing report by Doyensec. And they found the CSRF using the head method. And if you remember, a few years ago, there was the off CSRF in GitHub that used exactly the same method. So there was code like this, which sort of explicitly checked if the method is get, and then there was some things that were happening if the method was get that were not state changing, because the get is not subject to CSRF protection, so it cannot change or modify any data. So in context of GraphQL, speaking directly, get should only be allowed to do GraphQL queries and not GraphQL mutations. But here there was the explicit check for the get method, and the thing is, automatically the router would send head requests to the same sort of piece of code. So heads would implicitly land in the same function as gets, but then when it comes to the check like this, head is no longer treated the same way as the get is. So head would not have the CSRF protection and then not get to this non-state changing part of the source code. So it would land in the same place as post would, and you could easily just have the query in the URL parameter. So a very, very nice report. I really like the one in GitHub a few years ago, and I really like this one as well. And this is everything when it comes to the back classes in GraphQL. Again, appreciate you sticking around to the end. If you want to deepen your knowledge even more about GraphQL, check out the full article, check out the report database, and if you prefer just sticking to the free stuff, check out the playlist that's on your screen right now. For now, thank you so much for watching, and goodbye.